All right, we are recording. While Caden's passing that out, I say this a lot, but 9 times out of 10, I know the answer. Did you do this last year, or have you ever heard of this? This is various subsets of real numbers. I call it classifying numbers. It seems a little bit easier. That's like, what's a whole number? What's a counting number? What's an integer? What's a rational number? Things like that. You guys heard of that? Yes? You got to talk loud. I got those things on your face.
Yes.
Yes, good, my man. So as you see right here, and I don't know if you've noticed in Google Classroom, but I load all your handouts in there too. So you actually have a digital copy too, just of this, where your actual people are moving. Like see the chick here, she's moving, and little star, they're moving. And this YouTube link is live. It's a hyperlink. So if you click it, it pulls up a hyperlink for you and you can pull it up. But I've already got it pulled up here. We're going to watch him. Okay? Say, okay.
Okay.
And it's not that I want him to teach you. I just really, really think this is a great analogy for us to start with. So I'm going to push play, and you are going to watch. Maybe I'm going to push play.
Videos to see if we can classify them into different types of number categories. So let me draw the categories. So this circle over here, this represents all of the numbers that can be represented as a fraction of two integers. And of course, the denominator can't be equal to 0 because we don't know what it means to put a 0 in the denominator. So let's call these, or the standard way of calling these things that can be represented as a fraction of two integers, we call these rational numbers. Rational numbers. And if something cannot be represented as a fraction of two integers, we call irrational numbers. Irrational numbers. Irrational numbers. And the size of these circles will show how large these sets are. There's actually an infinite number of rational and an infinite number of irrational numbers. So these are the irrational numbers. Irrational. So these cannot be represented as a fraction of two integers. And then within rational numbers, you have integers themselves. So I'll do that in this blue color. Integers. So integers are numbers that don't have to be represented as a fraction or a decimal. So these are integers right over here. Integers. And then a subset of integers are whole numbers. So if you essentially say the non-negative integers, you're then talking about whole numbers. So let me do that subset right over here. So these are going to be the whole numbers. So whole numbers, whole numbers right over here. And actually, let me just label it all. These are rational. Let me do that same color. Rational numbers, and of course, irrational numbers. Irrational numbers. Irrational numbers. And an integer, well, if I could say, well, that is an integer. Let's think about the integers. But I wouldn't say let's just think about the rational. I'd say let's think about the rational numbers. All right, now that we have these categories in place, let's categorize them. Like always, pause the video. See if you can figure out what category these numbers fall into. Where would you put them on this diagram? So let's start off.
He said pause the video. Let's see if we can try that.
3.
Hey, stop.
This is positive 3.
We started again without me. Okay, so you guys know most of this. We're going to talk a little bit more about it as we get further into it, but this is shouldn't be new to you guys, okay? You did this last year, especially if you were in class with Miss Potok, paying attention, doing everything she asked. You should memorize. You should know a lot of this. So the number 3, actually before I start, change my mind. See, there I go. Changing my mind. Where is, okay. So before I start, actually I'll leave that there. There is a missing circle down here. What is the other one? Does anyone know? He doesn't have it in there. Just yell it out. Anyone? Anyone? You don't know?
Prime.
No, not prime. Natural. Who said that? Yes, thank you, Kyle. Natural. I'm going to put nat because I can't write as small as he does. Natural numbers. Are you with me?
Yeah.
What are natural numbers? So are natural numbers and whole numbers the same thing?
Yeah.
Then why do they have two separate categories?
Which one's different?
Which one?
Natural numbers.
Well, they're different from each other. Which one's different? Which number? If I said to you, count to 50, count to 50. Count to 50. 1. What do you start with? 1. You naturally start with 1, right? If I say count to 50, you naturally start with 1. Yes? So those are natural numbers. Whole numbers differ from natural numbers by one number. What is it?
0.
0. One little baby thing. 0 is a whole number. Are you with me? Everybody still cool? Yes? No? Caden, you're shaking your head. Are we still good? So where does 3 go? It goes in natural numbers. Can it go in whole numbers too?
Yes.
What about an integer? No, it's not an integer? Everybody says no? What about rational?
No.
So 3 is only natural and whole?
Yes.
Do you guys not understand the concept of a bullseye?
If it's in one of them, they're in the rest.
Ding, 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 ding. You win. Yay, Sarah. I want you to repeat after me. Well, I'm going to ask you a question, then I want you to answer it the way I tell you to. What numbers are rational? The answer is all of them, except irrational, and we'll get there. But in our life, our day-to-day world that we are living in this 7th grade math room, what numbers are rational? All of them. That was, Yandel was the only person that said anything. What numbers are rational?
All of them.
That's still not everybody. What numbers are rational?
All of them.
All of them. Guys, this is one of the hardest things you do this year because it's not relevant, in my opinion, you're not going to be asked what's an integer when you go buy a loaf of bread at H-E-B. Okay, it's just something you have to memorize. There's no math calculation, nothing. Okay? You just have to memorize it. So what numbers are rational? All of them. Okay? So where do you find integers?
Everywhere.
No.
Whoa. Negatives. It's the negative numbers.
Where do you find integers?
Number line.
On a number line. Somebody last period said the wall. I'm like, really? Do you see an integer over there? What about right here on that wall? What about down here? Is that an integer? Where do you find integers? On a number line. Okay, so you guys are really good with what whole numbers are, right? Whole numbers and natural numbers. Whole is 0, 1, 2, 3, blah, 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 and natural is everything but 0, right?
Yeah.
Integers are on a number line. That means whole numbers and their opposites. That means that's where your negatives come in. Rational numbers have a decimal or a fraction that cannot be divided out. Okay, so I want to let him put a few of these numbers in here and see if you guys agree with him.
It can be definitely represented as a fraction. You can represent it as 3 over 1, but it doesn't have to be represented as a fraction. It literally could be just a 3 right over there. But it's also non-negative. So 3 is a whole number. So 3, maybe I'll do the color of the category. So 3 is a whole number. So it's a number of that set. But if you're a whole number, you're also an integer, and you're also a rational number. So 3 is a whole number, it's an integer, and it's a rational number. Now let's think about negative 5. Now negative 5, once again, can be represented as a fraction, but it doesn't have to be. But it is negative, so it's not going to be a whole number. So negative 5 is going to sit right over here. It's an integer, and if you're an integer, you're definitely going to be a rational number, but it's not a whole number because it is negative. Now we have 0.25. Well, this for sure can be represented as a fraction. This is 25 hundredths right over here. So we can represent that as a fraction of 2 integers, I should say. It's 25 hundredths. But there's no way to represent this except using a fraction of the 2 integers. So 0.25 is a rational number, but it's not an integer and not a whole number. Now what about 22 over 7? Well, here it's clearly represented already as a fraction of 2 integers, but I don't think I can represent this any other except as a fraction of two integers. I can't somehow make this without using a fraction or some type of decimal.
What he means is he can't divide it out.
Repeat. So this right over here, this would also be a rational number, but it's not an integer, not a whole number. Now this over here, 0.2713, the 13 repeats. This is the 0.27131313. That's what that line up there represents. Now, you might not realize it yet, but any number that repeats eventually, this one does repeat eventually, you have the 0.13, or you have the 0.27131313. Any number like this can be represented as a fraction. For example, and I'm not going to do it here just for the sake of time, but for example, 0.3 repeating, that's the same thing as 1/3. And later on, we're going to see techniques of how to convert this to a fraction of two integers. But for our sake, we just know that this can be represented as a fraction of two integers, just the way that 0.3 repeating can be. And so we would put this under rational numbers, 0.2713 repeating. But you have to represent it as either as a decimal or a fraction of integers. If you didn't have to, then it could have been an integer, but we'll throw it up there in rational numbers. Now the square root of 10. This is interesting. So any square root of a non-perfect square is going to be irrational. So this is going to be irrational.
Okay. Here's where the good learning comes. Y'all ready? Who can tell me, you can either define it or give me an example. Do you have a question? You can either define it or give me an example of a perfectly square number.
2.
No.
It's my brother taught me square root.
Awesome.
I forgot.
You can either define it or give me an example of a perfectly square number. Yes.
12.
No, not 12.
4.
4 is the perfect square. What's the worst thing that's going to happen?
Wait.
I mean, he said 2, I said no. He said 12, I said no. That's about as mean as it gets.
10.
So what?
10.
10 is not a perfect square. Yes, Caden.
14.
No. Peyton.
6.
No.
8.
No.
3.
No.
1.
Yes. You'll catch a pattern in a minute. The best way to learn it is to touch that hot stove, guys, and
0.
pull that hand back. Did you say 0? Yes, 0. Yes.
7.
Not 7.
8. Wait,
Still not 8. The best way to learn is to touch that hot stove, guys. Make a mistake.
64. 11.
Did you say 64? Yandel, you cannot talk anymore. That's a big hint right there, guys. That's a big hint. Have you figured it out?
Yes, I have.
Okay, no words. You cannot talk.
Huh?
You got to let everybody else figure it out. Allison.
8.
No.
Wait, is it going back?
Go ahead.
61?
Say it louder. 61? No.
16?
16, yes. When I get them in order, it'll get easier. Somebody else throw one out.
24?
Not 24.
52.
No, remember back on the beginning assignment when we did 5 squared?
Yes.
What did we get?
25.
You are not allowed to talk.
Sorry.
Peyton. 70? No.
44?
Not 44. No.
54. 24. Oh, -1?
Gracie.
74? 72?
I just gave you one.
Yeah, I just say it out loud.
25.
Say it out loud.
You will. You'll get it. I promise you will get it. I promise you will get it. All these numbers have something in common. All of them. If you think hard enough, if you study hard enough, really look at them and think, geez, this is math. How do I get there? Allison is busy at work over there. Tell me, Allison, you got another one?
I'm trying to figure it out. I think at first it was times 4 and then.
It's not times 4. Because 4 times nothing gives you 1. Nor 25.
Or no,
nor
at
0.
first it was plus 4.
Oh, yeah, no. 1 plus 4 is not 4. It's 5.
Everybody, I don't get it.
Come on. Try it. You don't get it? Put your nose up. Come on. Somebody throw a number out, please. What's it going to hurt? Just keep it below 100.
34.
Not 34, but you're super close. Yes.
33. 35. 36.
36.
Wait.
Even if you're just guessing, you will see the pattern. I promise. Keep trying. Keep trying. Keep trying. Yes.
46.
Not 46.
44.
47.
40. 42.
Kyle, say it loud.
41. 48.
Not 48.
41. What? Can I say one?
66.
69. 69.
Nope.
Alright.
I'll get it.
You will.
40. 75. 74. 60. She said I could say it. Right?
Matthew? What do you think?
84.
84?
Yeah.
No, not 84. Come on, guys. You're taking longer.
82. 38.
82.
Still not 82. If it was 82, I'd have written it down when he said it.
86.
74.
Still not 74. You guys are saying 74. You're not counting by anything.
80.
You are not count. This is a perfectly square number.
Okay.
I told you we did one on the beginning assignment. You did 24 minus 5 squared. And you told me 25 was a perfect square number, and I wrote it down. Think. Use your brain. You are not stupid. Use your brain. You are all brilliant, brilliant, brilliant people. Think. We did it on the beginning assignment.
36.
36 is already written on there.
I figured it out now.
Okay, good. Then you can't talk. Keep trying.
15.
No.
Can I just help them?
No.
46.
You're just guessing. Guys, think. I wrote it down. I wrote 5 squared equaled 25. I wrote that on the board when you did your beginning assignment. Okay? And then I wrote 25 is a perfectly square number. Look at the other numbers. What does that have in common with 25? Obviously, they're not multiples of 5. So it can't be that.
So they're all squared by 2?
They are all, yes. But I need some more.
20? No.
You hush.
100?
100! Yes! Think about it. Everybody loves 100. It's one of our favorite numbers because it's easy. Why is it so easy?
200?
Not over
100. 81?
81! Yes! Peyton has got it. Oscar, yes.
91?
Not 91, nope.
94?
Nope.
96?
I'm only missing two major numbers,
I
yes.
think I know 41.
Nope.
I think I know
Go ahead.
49. Darn it. That is one right. Oh, 9.
9! Kyle has figured it out. And one more.
18.
No. I'm going to write them in order. Maybe you'll figure it out. 0. Maybe I'll write them in order. 1, 4. What's next? 9.
16. 25. 36. 81.
You stop talking. There's one missing right here.
81. Or wait, we are
49.
There you go. Who said 49? Yes, Gracie.
I said 49.
I know, but you're not allowed to talk, so I'll ignore you. And then we got 64. We got 81, and then we got 100. Okay? So, this is how we do it. What is 0 times 0?
0.
What is 1 times 1?
1.
2 times 2?
4.
6.
6.
3 times 3 is not 6.
Oh. 16.
Do you get it?
36.
Do you get it?
Yes.
Now, 7 times 7, 8 times 8, 9 times 9, 10 times 10. What's next? Not you. Which is? 121. And then what's next? 144. And it keeps going. Now, for those of you that have not observed anything around the room, which is all of you, if you look there to the left of Sierra and Gracie, on the red, yellow, and orange poster, it says common squares and square roots to 25. It's right there. Okay, so if I ever ask you what is the square root of blah, 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 it's only going to be a perfect square, and it's right there. If I ever say what is 13 squared, you're going to look up there and you're going to say, oh, that's 169. Okay? Are you with me?
Yes, ma'am.
So, my whole reason behind this, have you learned now, are you never going to forget a perfect square? Nope, you are not, right? You know it, because it's a number times itself. Why is it not 2? Because how do you get 2 when multiplying?
2 times 1.
1 times 2 or 2 times 1, that's it. Why is it not 10? 10 is a very friendly number, but why is it not 10? How do you get 10 when multiplying? 1 times 10 or 2 times 5, and that's it, right? No, nothing times itself. Are you with me? Is everybody with me? Okay, my whole point behind this, when you come over here to irrational numbers, we in 7th grade math are only going to deal with one major irrational number throughout the year, and it's not the square root of 10. But anything that is not perfect, are you listening to me? Anything that is not a perfect square, for example, the square root, we're going to pretend that's not negative. For example, the square root of 25, what is that? What is the square root of 25? 5. So that's 5, right? That's a natural number, right? That's a whole number. Is it an integer?
Yes.
Yes. Is it a rational number?
Yes.
Because what numbers are rational? All of them. Okay? Irrational numbers are the square root of anything that is not perfect. For example, the square root of 10 is an irrational number. Are you with me? And then the only irrational number we deal with is one that you've heard of, and it's on the wall in this room, written for you. It does not say, hey, this is an irrational number, but it is on the wall. What do you think it is?
Right here.
There is one that we deal with. You're really scared of it. And it's on the wall somewhere in this room. Because it's really long.
Oh.
Pi. Pi is our irrational number that we deal with. Okay? We good? Everybody cool? What is this? What does this fraction line mean to do?
Divide.
Divide. So what does this equal?
7.
No.
2.
2. So that's a
whole number?
It's a natural number. It's all of them, right?
Yes.
What about 2 times pi?
I never knew.
10. Wait, what?
It's irrational. Who said that? Yes. Because pi is irrational. That means anything times pi is irrational. Right?
Mm-hmm.
And then I want to come back over to this decimal that he was talking about right here. What does this line mean? It repeats. So do you know what's coming next after this?
Yes.
So rational number. Say that.
No. What? Next?
Your rational numbers, you know what's next. No matter how long it is, if you know what's coming next, it's rational. Because what numbers are rational?
Not rational. All numbers.
All of them. Okay? That's not 100% true, but all of them that we deal with are rational. Are you with me?
Yes, ma'am.
Alright, so we're gonna move out of him. We're gonna go back to our packet here. Maybe. And we are going to look at what you have in front of you. So the first 2 or 3 pages are simply my explanation of what I've already explained to you. Counting numbers are natural numbers. That's what you naturally say. Are you with me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whole numbers. What's the difference in a counting number or a natural number and a whole number?
A natural number is 0 or 9.
What is the difference? Whole numbers have 0. What's the third subset is integers. Where do you find them? I want you to repeat after me. There is no such thing as negative integers. They're just negative numbers. They're called integers. Negative numbers. Positive numbers on the number line. Positive numbers. And their opposites are called no.
Integers.
Integers. Positive numbers are opposites. Where do you find them? On the number line. If it's got a decimal, it is not an integer. It is a rational number only. Next page talks about rational numbers. Rational numbers means you know what's, like right here, do you know what's coming next right here?
Yes.
Yes, so it is rational. And then lastly, we have irrational. The one that we deal with is what? Pi. And we don't even deal with irrational much. The only time you're going to deal with anything other than pi is this week. All right. Scrolling on through, keep going past that next page. It's just more definitions. I found this stack of funnels earlier this year, so this is new this year. I thought it was a great representation to help you. All numbers are real. And then you got irrational over there by himself, right? Because he don't like to get along with anybody. They're not very nice. They got to sit alone. But this set of funnels right here I thought was fabulous. Because if it is natural, would you give me a natural number?
3.
3. If it is natural, oops, I need to change that color. If it is natural, then it is whole. Then it is an integer. Then it is rational. All of them. Okay? So if it's natural, it goes in everything. If it's whole, it only goes in whole, integers, rational. That would only be 0. That doesn't go in natural. Everything else, like 1, 2, 3, 4, 5, all goes in all. Alright, so turn the page. We're going to look at these questions. If you are doing remote learning and you are listening to the video right now, be sure you follow directions on how to turn in paper assignments, because they are due for you too. Again, it will be exactly the same. Number 1, the number 0, 0.0987, 0987, 0987 is in which subset? First of all, stop yelling out. I told you you're muted. Can't talk anymore until I tell you you can talk. Do you know what's coming next?
Yes.
Yes. So what is the answer to this one?
Irrational.
It's irrational because we know what's coming next. It's integers because it's on the number line. You see that on the number line? 0.0987, 0987, 0987. That's on the number line.
Rational.
What is it, Gracie?
Rational.
It's rational. Do you know what's coming next? Yes. Is there a decimal? Yes. Look at number 2. The number 9 is not in which subset? The number 9. So if you go back to here, where does number 9 go? In all of them. So, whoops. So tell me about the number 9. Is it not in which subset? Where does it not go? Irrational. Does everybody agree with that? That pencil sharpener works now. This one, that one does not. That one does. Brand new. If you look at number 3, and you can just circle your answers. There's not a lot of show your work on classifying numbers. Do it. Hurry. I can talk loud. Number 3, the square root of 31 is in which subset? So, square root 31, where does it go? Gracie's already answered one. Matthew's already answered one. Let's hear from somebody else. Where does the square root of 31 go? Is it a perfect square? Question 1. Yes or no?
No.
No. So where does it go? Yell it out.
Irrational.
Irrational, because it is not a perfect square. Perfect. Let's look at number 4. Counting numbers are also known as blank. No, you cannot answer. Please don't be that kid. Guys, I like a community. I believe I talked to you about this the other day. Just yell it out. If I don't want you to talk, I will mute you, just like I've done Yandel. I will just say you can't talk anymore. That's because I will know. So I know you've been trained your whole life to raise your hand and not speak out of turn, but I like to have a conversation with you. Okay, I like to be in a conversation with my kids. Okay, so just, what do you think it is? You think it's B, natural numbers? Does everybody agree? You do not agree, speak now. Good, I agree. Number 5, which numbers differ? I just made that go away. Whole numbers differ from counting numbers by what number?
0.
0. Does everybody agree?
Yes.
Yes, awesome. If you're wrong, the worst thing that's going to happen is I'm going to say no, and then we'll get it right. Number 6, whole numbers and their opposites form which subset? Does everybody agree with integers?
Yes.
Good, me too. Turn the page. This is going to be your assignment, but I'm trying to get to it and through it before this timer goes off to clean, because you can do number 1 on your own, but I want you to pay close attention to number 2. That says which set of numbers should be placed. Are you paying attention tonight? Because you're not. Because you turn around and look in the other direction. Which set of numbers should be placed in the region where both circles intersect? Do you see that says multiples of 2 and multiples of 3? What is a multiple? Like what? Like what are multiples of 2?
Like 2, 4.
Yes. So it's count by, right?
Yeah.
So you're looking for which numbers fit in here. What's this diagram called? There you go. So I want to make sure you're clear on that one. And then I want to look at number 3. So turn the page and look at number 3. In this Venn diagram, which number does not belong in the intersection of the 2 circles? So you're looking for what does not fit. And that says factors of 42 and factors of 56. What is a factor? I heard somebody say it, so I'm just going to write one. The factors are 2 and 6. The numbers in a multiplication problem. So basically, you're going to go through here and see which of these numbers does not work with 42 and 56. Are you cool there? Just want to give you a heads up on your assignment that you got to do by yourself. And then if you keep going, look at number 8. Number 8 scares people every single time they do it. But if you read, it's really not that hard. If x equals 36 and y equals 4, how many of the following are rational? So if you look here, that says the square root of x plus y. What's x?
36.
And what's y?
4.
And 36 plus 4? It's 40. Is that rational? No. Right? The next one says the square root of x times y. What's x? And what's y? And 36 times 4. I'm going to do this one for you because I'm just that cool. Is 144. Is the square root of 144. Is this rational? Yes. So you're going to do the same thing with these 2 and figure out how many of them are rational. You got it? Hold on. Don't do anything yet. And then I want to make sure you understand the little bull's eyes on the back right here. Okay? Negative 10 divided by 2 is negative 5. You're going to cause this class to have homework, more homework than any other classes have to constantly get on you. Tell you to stop talking, stop whatever you're doing, all that kind of stuff. So that's negative 5. Where does negative 5 go? In the integers. You can either put negative 5 in there or you can put negative 10 divided by 2. I don't care. All right? This is the square root of 36, which equals 6, which is a natural number. So you can either put the square root of 36 in there or 6. It goes in all of them, but you can put it in the one that's most appropriate. Are y'all with me what I'm saying on there? 4/9, you can't reduce that, can you? So that's a rational number because it's a fraction. Are you with me?
Yeah.
All right. So when should you do this?
Can I?
Pause. Why? I'm here. If you need help, ask me. All right. When is it due? Tomorrow. When you walk in the door. If you've done it, you'll get a paw print and a 100.